Question number 14. The available power required at the receiving antenna is 10 power minus 6 watts. Transmitting and receiving antennas have a gain of 40 dB each. The carrier frequency is 4 GHz and the distance between them is 30 miles. The required transmitted power is dash. So I'll show you in the form of a picture. So there is a transmitting antenna and there is a receiving antenna. So this is a transmitter and this is a receiver, assume. So these two towers are separated by 30 miles, that is given in the question. And also he is asking what is the transmitted power. He is asking what is the transmitter power and the distance between them is 30 miles given, and each transmitter, the transmitter and receiver having the gain of 40 dB. This is having a gain of 40 dB and this is having a gain of 40 dB. Also it is given that the receiver the receiver can received a power of 10 power minus 6 watts. Then what should be the transmitted power so that it will receive 10 power minus 6 watts as the power? And also it is given that the signal, see, it is quite simple. There will be two towers. One signal has sent, this signal has sent with a frequency of 4 gigahertz and it has a transmitted power of some x, we don't know, and once it receives the receiver, the power of that signal will be 10 power minus 6. Then what is the transmitted power he is asking? So just a signal, it is transmitted with some power pt. When it receives, its power will definitely reduce because due to all the obstacles in the atmosphere, everything, it will hit and collide. Finally this power has came to a value 10 power minus 6. Then what could be the received power per transmitted power so that the received power is 10 power minus 6 he is asking, and the distance between transmitter and receiver is 30 miles already given, and the frequency of the signal is 4 gigahertz. Now let us see this type of questions. When a signal, power, distance are involved, directly use Friis equation. This equation is used many times in electromagnetic theory, that is the transmission lines. So PR indicates the received power is nothing but transmitted power into gain of the transmitter. GT is the gain of the transmitter, GR is the gain of the receiver, PT is the transmitted power, PR is the received power. 4 is a constant, pi is a constant, mathematical constant. D is nothing but the distance between the receiver and transmitter, the distance between transmitter and receiver, and lambda indicates the wavelength of the signal which is transmitted. Here it is given frequency. Now let us convert all the given parameters into MKS form. That is, D is given as 30 miles, but we always calculate the things in meters, MKS. So 30 miles is nothing but 1 mile is nothing but 1.609. Try to remember this. If you don't know this, you have gone with this question, even though if you know Friis equation. 1.609 kilometers. So this I can rewrite as 30 into 1.609 into 10 power 3 meters. Next, lambda. We need to calculate lambda. C equal to F lambda. So F is nothing. Lambda is nothing but C by F. This is one more formula we are studying from our childhood. C is nothing but F lambda. C is nothing but velocity of the light in air, 3 into 10 power 8 divided by frequency. Frequency is 4 gigahertz given already. 4 into giga. Giga is nothing but 10 power 9. So this will become this and this gone 0.075 meters. So D and lambda are ready. Next, GT and GR, it is given as 40 dB, but we need to convert into normal value, in the sense dB value, it should not be in dB. So 40 is nothing but 10 log G, GT or GR, whatever. So this and this gone, this is base 10, so therefore G is nothing but 10 power 4. So from this, GT equal to GR equal to 10 power 4. See, purely is checking your aptitude. Everybody know the formula. Okay, now also it is given that PR is given. PR is given as 10 power minus 6. So everything is ready. Now it's a cakewalk. So just make use of this, this two, this and this. Finally, you substitute in the formula, definitely you're going to get the answer. So PR is known, everything is known, just you need to calculate PT. So after calculation PT, you're going to get, just substitute all the values, everything I have told you. So PT you're going to get 0.64 watts. Now let us check the options. Yes, so the right choice is option A. Now let me tell you the extension to this concept or the formula. So here are the formulas based on Friis transmission. These formulas are very important, among which any one of the formula can be framed as a question. So try to remember or try to get the logic of all these formulas. So in my view, if you remember this formula, it will help you to get remaining all of the formulas. The formula is PR equal to PT GR by 4 pi d by lambda whole square. I already explained what each letter indicates. So try to memorize this formula, and the units is watts, not dB. Now if you want the same expression in dB, just apply 10 log to the base 10. All are having base 10. I have not indicated because it is understood. On both sides, apply log 10 log on both sides. If you apply 10 log here, 10 log, multiplication in normal domain will become addition in logarithmic domain. So plus, and if it is in division, this is in the division, so it becomes subtraction, and this 2 is there, hence the reason 2 into 10, it becomes 20 log 4 pi d by lambda. This 20 log 4 pi d by lambda is called path loss, and it is asked in various exam many times. So path loss is nothing but 20 log 4 pi d by lambda, 20 log 4 pi d by lambda. So this is the path loss. So try to memorize what is path loss. Whatever is there in the denominator, the logarithm of it will become 10 log of that will become path loss. This 2 into 10 become 20. So this is the path loss. One more formula which is sometimes asked in the exam is nothing but received power. Received power is nothing but EIRP into received gain into path loss. The denominator is path loss, that you understood anyhow. Numerator is PTGT into GR. Instead of PTGT, I wrote EIRP. EIRP is nothing but effective isotropically radiated power. Once again I am repeating, effective isotropically radiated power. Effective isotropic radiated power is nothing but PTGT. Okay, this is nothing but EIRP. So into GR divided by path loss. So all are based on the first formula. All are based on first formula. I'm making some derivations from that. That's it. And finally, last formula is the receiver gain can be rewritten as 4 pi into AE by lambda square. AE is nothing but effective aperture. Effective, you might have studied in antennas. Effective aperture or antenna area of the receiver. So try to memorize, because all the questions you are saying they are formula based. Okay, so we'll see in the next question. Thank you.